Alright, so we're going to look at frequency distributions. Now, frequency distributions are a way of putting our data in order. And so we're going to look at how to construct these. And I want you to realize we're going to start doing this by hand so that we get the concept. Then we're going to switch to doing it by software. You're going to see that frequency distributions are a pain to do by hand. You know, if we have, 5 or 6 pieces of data, 10 pieces of data, it's not too bad. But once we get 20 or more pieces of data, these things are, the software is going to be our friend. And so I'm going to push towards problem sets that use the software, not because I want you to struggle with the software or anything, but because I want you to appreciate how it helps. And so what we have with a frequency distribution is they're usually in a table, and what you'll have is a class and a frequency. And we usually use like a script EF for frequency. And I'm again going to use the examples from the lecture notes in the book. The class is a range of numbers. And so this data, whoops. Get my classes in here. This data is arranged in classes. The smallest value is around 1 and the largest value is around 30. Now we'll find how we exactly squeeze all the data in our classes. And what we then do is we count how many times values fall within these classes. Now you will find that due to some of my programming in astronomy, we'll call these things bins. And so I'll say class or bin, because there's a tendency to think of them as a bucket or a bin, and you count how many things are in them. Now, some things to note about this. This tells us a lot about our data, and we can start looking at patterns in the numbers, and that's our job is going to be finding patterns in numbers. But when we create these things, we lose some information. So notice that the difference between each of these larger numbers is 5. And so these classes have a width of 5. There's 5 possible numbers that could be in here. And we know how many were collected in here. But we don't know which particular ones they were. I mean, this data could have been 4, 4, 4, 3, 1 for these 5, or it could have been 1, 2, 3, 4, 5. As far as we know, these are the same. So when you start putting together frequency distributions, you lose some information. But what you're hoping to gain is information that shows you a pattern. And so we've taken whatever the underlying data was, and we've found clumpings or groupings of them. Now, what we're going to call this the lower class limit. And when I point to this lower class limit and the upper class limit, that's for each thing on this side. So 1 is the lower class limit in the first class. 5 is the upper class limit in the first class. 6 is the lower class limit in the second class. And 26 is the lower class limit in the sixth class. And so this tells you what the smallest value of these 4 things could be. And this tells you what the largest value of these 4 things could be. And the difference between adjacent class limits is the width. And so this has a class width of 5. And from the largest possible value to the smallest possible value, not in the bins, but in the actual data. So in the actual data, remember when I wrote x max minus x min? I take all of my data and I grab the largest value and the smallest value. That's the range of the data that we can have. I'm going to put together some rules on how we can create these things, and then I'm going to pause the video and I'm going to shift over and we're going to build some. And we're going to do, these videos you're going to find are going to be in little parts. I'll get some concepts together, get your notes together, then we'll do one, and so on. And so we want to make these from our data. So what we want to do is we want to do a couple of things. The first thing you need to do, and let me give this a title, change color and give it a title. So we'll say this is constructing frequency distribution. So you have data and you want to look for patterns in it. You want to see how it might cluster, or you might want to talk about it more generally. Instead of looking at all the different numbers, you want to talk about how the numbers kind of come together. And so we're going to call this constructing a frequency distribution. So the first thing you need to do is you want to decide on the number of classes. And there's an art to deciding on the number of classes. Sometimes your data, book says it's between 5 and 20. I've seen actually data sets where you've needed more than 20 classes because there's a lot of data in it. But your data will sometimes tell you that your choice is wrong. There's a rule in general that you take how many pieces of data you have, the n. And so let's say I have 50 pieces of data. And what I do is I do the number 2 to the k minus 1. And the thing that's the smallest and closest to that, that's going to be the number of bins I want. That's a rule of thumb. And this is really hard sometimes for people to understand about mathematics and observational mathematics, is sometimes you have to change these numbers if they don't work. For the homeworks here, I will give you the number of classes to use. But realize if you're ever working on real data, sometimes you'll say, what does it look like with 6 classes? And you'll look at it, and I mean look at it, you'll see your data looks like this. 1, 2, 3, 4, 5. Right? It might be spaced out, has some gaps in it with 6 classes, so you'll say, okay, let's look at it at 5, and maybe the spacings change a bit with 5. And it looks like this. And so one of the things you do is this is something that you decide. And there's an art to it. The more data you play with, you'll figure out what gives you the most information. Remember, when we make these frequency distributions, we lose some information. So you have to judge what you want to see coming back. But again, for the homework, I will tell you how many classes, and we'll get used to the mechanics of it. And so you decide on the number of classes, and this will figure out how spaced out your data is. Then you find the class width. And the class width is done by, you find the range of the data. Find the range of the data. And you divide it by the number of classes. But because this might have fractions and these are numbered things, you then round up. Because if you don't round up, you might cut off the range. And so this normally has a formula that says width. And I'm going to put x max minus x min divided by the number of classes. And this is in the equations in the book. You'll see that the book has a fold-out that lists equations for each chapter, and this gets mentioned in there. But remember, always round up. Otherwise, you might cut off your data. Then find the class limits. And so for illustrative purposes, I'll come back up here. These are the class limits, right? And so you want to find what these are. And you do this by use the minimum value as the lowest class limit. And then what you do is find the next. So remember, x min you put here. Then in your next minimum, your next lower limit is going to be the x min plus your class width. So if I'm finding my class, and I continue doing this until I get to the last one. Right, let's say I wanted n classes. I do this until I have the nth row. And so this is the x min plus n. Don't worry about the math here, I'll show you. And this gives me all the lower limits. But then in the upper limit from the previous class is this number minus 1. Well, that looks weird, right? Find the class limits, use the min as the lowest and the class width. Let's go back and look at this one that we had here. Remember how I said the class width was 5? So I start with 1, and I add 5, and I get 6. I add 5, and I get 11. I add 5, and I get 16. I add 5, and I get 21. And I add 5, and I get 26. And I have my 1, 2, 3, 4, 5, 6 width classes. There are 6 classes here. And now I've gotten all my lower ones. So I start with my lowest data value, and I add the width. Then to get the upper side of these, notice I subtract 1. 6 minus 1 is 5. 11 minus 1 is 10. 16 minus 1 is 15. 21 minus 1 is 20. And 26 minus 1 is 25. And then this very last value, well, that's 25 plus the class width again. And so we build a table out of that. And so we build our class widths. Then we go to our data, and for each piece of data, we put a tally mark. In the class for each piece of data. That fits within it. And then we count up the tally marks. And this is how we construct a basic frequency distribution. And what I'm going to do here is I'm going to pause this video and we're going to do one. I'm going to put some data up and we'll create a frequency distribution out of it.